Hey y'all, today we are going to be looking at angles. We're going to review angles and the parts of angles, types of angles. We're also going to be looking at the angle addition postulate. So if you want to pause the video and find these two worksheets that say 4 on them, these are the not the assignments, these are the notes pages. I'm going to go through this, okay? All right, so an angle is formed by two rays that have a common endpoint. So this is the first ray. It starts at B and it goes through C. And then this is the second ray. It starts at B and it goes through A. Okay, so those two rays make the sides or the boundaries of our angle. The common endpoint, this point here at B, is called the vertex. That's the point of our angle. And the rays, like I just said, the rays are called the sides. These are the sides of our angle. Okay, excuse me. So when we name an angle, we're going to use 3 letters. So you're going to think about it like you were going to trace it. So if I want to trace this angle all at one time, I'm going to start here at A, and I'm going to trace to B, and I'm going to go out to C, and then I'm going to pick up my pencil. Okay, if I start at B and I trace to C, I'm going to have to pick my pencil up and come back to B and trace A. So we don't want to do that. So when you're naming the angle, think about putting your pencil down, tracing to the vertex, tracing out the other way. Okay, the middle letter is always the vertex. The middle letter is the most important. Okay, that's the point of our angle. And if we're just using a single letter, then we're just going to use that vertex. Okay, so when referring to the measure of our angle, actually, let me do this before I do this. Let's say we could call this angle B, single letter with a vertex. We could have called it angle ABC. Notice that B is in the middle. So this is our symbol for angle, ABC. Or we could go the other way. We could start here at C, go towards B, and then back to A. So angle CBA. So these are the 3 ways that we could name this angle right here. The single letter coming this way, notice B is in the middle, going the other way, B in the middle. Okay. All right, when referring to the measure of an angle, remember measure is how big the angle is. We're going to use a lowercase m for measure. So when you see this little m in front of it, we read this, the measure of angle ABC is 60 degrees. Okay, so that's how we would read that. This little m in front stands for measure, and it's going to be how big this angle is. Okay, so this in here represents the size of the angle, how far it's opened up. Okay, all right, review types of angles. This angle is an acute angle because it is less than 90 degrees. This one is exactly 90 degrees. We call that a right angle. I'll put this in parentheses. A right angle because it is exactly 90 degrees. So anything smaller than this, so this is our right angle, anything smaller than this is acute. Anything opened further than this is obtuse, more than 90, but less than a straight line. So it's not going to be open up as far as this, and this straight line equals 180. So obtuse is more than 90. This is a big angle. Obtuse, more than 90, less than 180. And this is exactly 180. We call it a straight angle. Exactly 180. Looks like a straight line. Okay? So acute, obtuse, right, straight. You need to be familiar with those. Okay? All right, I'm going to skip the 2 examples. We'll go over those in class. I'm going to go down here to the bottom where it says congruent. Okay? If the measure of angle A is equal to the measure of angle B, so this angle A is 75 degrees, this angle B is equal 75 degrees as well, then the angles are said to be congruent. So the way we write that is we say angle A is congruent to angle B. Remember, the symbol for congruent is an equal sign with the little squiggly over the top. Okay, and again, when we're talking about values for the numbers, like the angles are 75 degrees, that's a number. We talk about the measure of them, and we say measures are equal. When we're talking about the picture itself, like this angle is the same as this angle, those shapes are said to be congruent with the equal and the little thingy over the top. Okay, essentially they both mean the equal, the same. All right. Okay, a couple more words just as a review. You should have already talked about these at some point. Let me switch to a different color just for kicks. All right, angle bisector. Bisect. Sect means to cut. Bi means two. Okay? Okay? Bicycle like has two wheels, right? So an angle bisector is something that cuts an angle into two equal pieces. Two equal pieces. Bisect means to cut in half. Bisect, cut in half. Bisect, cut in half. Two equal pieces. So something that cuts an angle in half is going to be a ray or something like that, or a line or a segment that divides an angle into two congruent angles or equal pieces. Two congruent angles. So in this diagram to the right, blank is an angle bisector. So this thing that goes right through the middle, that's our bisector. So it starts at B and it goes through D and keeps going forever and ever. So that's a ray. It starts at B and goes forever through D, one arrow. Therefore, we get two equal angles. So this angle up here on the top, this angle, I'm going to color it orange. This angle in here, do you see that? A, B, D. Angle A, B, D is congruent to the other angle on the bottom, C, B, D. This angle down here, angle C, B, D. Okay, and those two angles should look the same. So we put that little curvy mark when we're talking about congruent angles. Okay. All right, perpendicular lines, two lines that intersect at a right angle. It's called perpendicular. So these are like our intersections of our roads. Most roads intersect at right angles. The symbol for perpendicular is an upside down capital T, which is kind of part of our picture here, like this part right here, to show us that we have that right angle in there. Okay. So in the diagram to the right, we say that this line L is perpendicular to line M. So the way we can say that is L is perpendicular to M. Okay, and this little symbol, again, that's our symbol for right angle. That's a 90-degree right angle. Okay, and the last vocabulary word combines the two. So we have something that's perpendicular and a bisector. So this is perpendicular or right angle, right? Intersect or cross at a right angle. And what's bisect mean again? Bisect, cut in half. So it's going to do both of those things. So the two lines or the two things are going to cross at a right angle, but they're also going to cut something in half. So if we have a line, segment, or ray, perpendicular to a segment at its, what do we call this point in the middle of two equal pieces? Midpoint. So we have a right angle and we have congruent pieces, meaning that this is right in the middle. So LM cuts the thing in half. So LM is our bisector, and it is the perpendicular bisector to PQ. So this segment gets chopped in half. Okay. All right, so again, we're going to do these examples in class. We'll go through those. We might not go through all of them because there are a lot of them. So I want to look at angle addition postulate. This should be pretty straightforward. The only difference between angle addition postulate and segment addition postulate is what our initial picture looks like. So here we have two angles that add up to make one whole angle as opposed to two little segments that add up to make the whole segment. Okay, so if D is in the interior of angle ABC, so this is angle ABC, D is somewhere in here on the inside of this angle. So what that allows us to do is it allows us to connect and cut this big angle ABC into three angles. There are three of them here. Okay, so we have this angle right here, which is the little one. So the measure of angle ABD plus, this is across the middle, right? Plus this other angle on this side, this whole big angle right here, this is DBC, the measure of angle DBC. So the orange angle plus the pink angle together make this whole thing. This is the whole angle equals the measure of angle ABC. Okay, so another way you can think of this is you can think of this as being the angle on the left, this is the angle on the right, and this is the whole thing. Or sometimes the picture might look like this, where it's like this one's on the top, this one's on the bottom, still the whole thing. Okay, something to distinguish between the two sides or the two edges of it. Okay, so again, labeling is super important. Label, label, label before you start working. Don't try to do it without. Okay, all right, so let's do a couple of these and then we'll do some more during class as extra practice. Okay, so the first one says, using this picture, if the measure of angle ABD equals 48. So I'm going to go over here and I'm going to color ABD. ABD. And I'm going to put a curve inside that angle. So this angle is opened up 48 degrees. So I'm going to put a 48 right in there. And then the next one says the measure of angle DBC equals 78. So I'm going to color this orange. DBC. Now this one I'm going to put two little thingies because they're not the same. If I put the same curve in both of them, that would mean that they're congruent. They're going to be equal and have the same number. But I want to put a 78 for this one. Then it says find the measure of angle ABC. Do you see how that is the whole thing? So this big angle is all of this plus all of that, right? So together, 48 plus 78 will equal the whole thing. Okay, or we could write it out like this because it's actually the same picture. ABD on the left plus DBC on the right equals the whole thing. So 48 plus 78 equals 126 degrees. Okay. All right. So I wrote in pen, wrote a marker. So I drew myself another picture for question number 2 because they want us to use the same diagram. We're just going to have to relabel it. Okay. So the first one here says that DBC is 74. So I'm going to color that in. DBC. And I'm going to put a little curve thing. 74. Okay. Then I have ABC is 119. A, B, C. Do you see how that's the whole thing? So that's going to go out here like that. A big, huge arc around the outside. All of that gets a 119. Find the measure of A, B, D. So this piece right here is our question mark, what we're trying to find. Okay. So do I want to add these two together? Are these the two little pieces? No, we're trying to find a little piece. So this 119 is the whole thing. So these two little pieces need to add up to make 119. So if I already got 119, and part of that 119 we already know is 74, then whatever's left will be our missing angle. So 119 minus 72 is 45 degrees. 9/11. Yeah, 45. Cool. Okay, so when you just have numbers for the measure of the angles, it's pretty simple. It's either add or subtract, depending on what you're given in your picture, but you won't know that until you label your picture. So make sure you label, okay? And then the other way we could ask it is with a little bit of algebra, okay? So on this problem, they've already labeled for us. So I'm going to color this in. PQS, that's this angle right here, is 13x plus 4. SQR is this angle right here. Those are not the same, so I'm going to put two little curvies in this one. This angle is 10x minus 1. And then up here in the directions, they tell us that PQR, which is all of this, the whole big angle, is 141. Okay? So the rule is the two smaller angles, you see that? Angles. Two smaller angles add up to the whole thing. The two smaller angles add up to the whole thing, or add up to the bigger angle, right? So I'm going to start with the 13x plus 4. That's the left angle, plus the one on the right, 10x minus 1. And together, those are going to add up to equal this whole thing, all of this, which is 141. Okay? So just like when we were doing our segment addition, once we get to this point, there's no more geometry. Okay? We've already done all the geometry, so I'm just going to solve this. Grab my pencil. I'm going to combine my x's. 13x plus 10 more x makes 23x. And then I have a plus 4 and a minus 1. Plus 4 take away 1 makes positive 3. And then I'm going to get rid of this plus 3 by doing minus 3. 23x equals 138. I'm going to grab my calculator. Sorry. 138 divided by 23. Divide both sides by 23. X equals 6. X equals 6. And again, you should get a pretty nice answer for each one of those. Okay? So last step, we want to find the measure of PQS and the measure of SQR. So we're going to substitute our x equals 6 back in to those particular angles, okay? So I'll put it over here. PQS is going to be 13 times whatever x was, right here. 13 times whatever x was plus 4. I'm going to put a 6 right here. 13 times 6 plus 4 makes 82. So when I write my answer for an angle, angles are always in degrees. So I'm going to put a little tiny degree symbol. Try not to make it look like a 0. We don't want it to be 820. Okay, 82 degrees. And then we do the same thing for SQR. In SQR is this one. 10 times whatever x was minus 1. So 10 times 6 minus 1 makes 59. And we could do a real quick double check. Those two angles should add up to this whole thing, which we said was 141. If you add those together, it makes 141. Okay? Awesome. Here's my suggestion to you. Now that you've gone through the notes, I would suggest going back and doing some of the examples and seeing if you get the same answers that we get when we go through it tomorrow. That would be really great practice and preparation for tomorrow's class. Okay? Make sure you have all of these written down and bring them with you to class tomorrow. Okay? All right.